the second video in the series that I'm going to do about decimals. So the first video, we kind of just did an introduction, like what is a decimal? We talked rational numbers versus irrational numbers. We looked at place value of decimals. We looked at how to write out decimals in words and then to reverse that. So take a decimal that's written out in words and write it in decimal notation. We then talked about how to take a decimal and write it as a reduced fraction or mixed number. And then lastly, at the end of the video, I went ahead and showed you how to convert fractions to decimals, but the fractions had powers of 10 as the denominators, very specifically. So for this video, what we're going to do is we're going to talk about rounding. So rounding decimals is very, very similar to rounding whole numbers. There's just like a teeny tiny difference. So we'll talk about the rounding. And then we will talk about comparing decimals, so determining which decimal is bigger. We'll talk about ordering decimals, so putting them in order smallest to largest. And then the next video, we'll talk more. My hair's sticking out right here. It looks kind of weird. Anyway, we'll talk more about converting fractions to decimals. So all fractions can be written in decimal form. At this point, you know how to convert fractions where the denominator is a power of 10. In the next video, we'll talk about all fractions regardless of what their denominator is. And then we'll look at comparing fractions to decimals and ordering a group of fractions and decimals mixed. Okay, so I'm really tripping about my hair. It's like sticking out. Anyway, it doesn't matter. Okay, so let's take a look. So rounding decimals. I'm showing you this now. In the previous video, I was kind of still undecided on what order I would teach rounding versus converting fractions to decimals. And I decided to teach rounding first because there is a situation where some of the fractions that you convert, even though you can get an exact decimal equivalent, it may be something that doesn't happen quickly. It may be several decimal places long. So a lot of times you'll be told to round to the nearest hundredth or the nearest thousandth place. So let's talk rounding first. So it's very similar to rounding whole numbers. So basically, if you can round whole numbers, you can definitely round decimals, okay? So you locate the rounding digit. And you locate the rounding digit based on place value. So if I tell you to round to the nearest hundredths place, you want to find the digit in the hundredths place, okay? The digit to the right tells us to round up or down. Okay, so this is so far just like rounding whole numbers. So if this digit is less than 5, round down. If this digit is 5 or more, round up. So let's look at what that looks like. So rounding down. Leave the rounding digit alone. So if you're going to end up rounding down, you leave the rounding digit alone. You don't add, you don't subtract, you just leave the rounding digit as is, and then drop off all digits after. All right. Now, when you're dealing with whole numbers, you wouldn't drop off the digits after the rounding digit. You would make them all zeros. So that's really the only difference. Instead of making all the digits after a certain point zeros, you just drop them off. Rounding up, we add 1 to the rounding digit. And then we drop off all digits after the rounding digit. So it's a lot of writing, but it's worth having it written out. and sitting in front of you, okay? So rounding decimals, similar to rounding whole numbers, you locate the rounding digit by place value. The digit to the right is the one that tells us to round up or down. So you find the rounding digit by place value. You look one digit to the right. If that digit is less than 5, you round down. If that digit is 5 or more, you round up. In order to round down, you leave the rounding digit alone, chop everything after that off. Rounding up, you add 1 to the rounding digit, drop off all digits after that. So let's see what this looks like in practice, okay? So for these examples, we're going to round all of them to the nearest thousandths place. So let's say I have 15.0936. We want to locate the digit in the thousandths place. That would be this digit right here, the 3, okay? We look 1 digit to the right, the 6, and that tells me to round up because 6 is 5 or more. So I'm going to use one of the squiggly equal signs. Anytime you round, use the squiggly equal sign because it tells you that whatever you're saying after is approximately equal to. So since I round up, I'm going to add 1 to my rounding digit, which is 3. And then I'm going to chop off all the digits after the 3. So this is going to be approximately 15.094. All right. And remember, you chop everything off after the rounding digit. So after you add the 1 to the rounding digit, just get rid of everything after that. What if I have 0.98314? Now we're rounding to the thousandths place. So again, we're looking at the 3. We look 1 digit to the right of that, and we have a 1. That tells us to round down. That means I leave the rounding digit alone, so the 3 stays a 3. And then I chop off everything after that. Okay. What if I have 364.1597? Okay. I locate the rounding digit, which is the 9. I look to the right of that. I have a 7, which tells me to round up. Now, anytime you're rounding up with a 9, it's always a little weird because when you add 1 to 9, it really makes it a 10, and then you carry the 1 again. So adding 1 to 9 makes that, I'm going to do a little side work over here. We're going to add 1 to the 9. It makes it a 0 because it's really 1 plus 9 is 10. So I keep the 0, carry a 1. 1 plus 5 is 6. Drop down the 1, the 364. So we would say this is approximately 364.160. But hopefully you'll remember from the previous video, I told you that these zeros at the end of a decimal are not necessary. The only time you would keep these zeros at the end of the decimal would really be if you were dealing with money and you had dollars and cents. But otherwise, it's kind of like keeping a decimal unsimplified. So we would say that this now is 364.16. So anytime you have those zeros at the end of the decimal, just get rid of them. Let's do one more page of rounding. So let's round to the nearest hundredth this time, okay? So what if I have 2.9861? Well, the rounding digit is 8, all right? The digit beside that to the right is 6. That 6 tells me to round up. So this is approximately 2.99. Okay, you add 1 to the rounding digit 8, and then you chop everything after that off. What if I have 4.308? Okay, now in this case, the rounding digit that's in the hundredths place would be the 0. So looking to the right of that, I have an 8. That tells me to round up. So rounding up means I add 1 to the rounding digit. So the 0 becomes a 1, and I get just 4.31, drop all digits after that off. What if I had 32.0539? Okay, Rounding digit is the 5. It's in the hundredths place. I look one digit to the right and I have a 3. That 3 tells me I round down. That means the 5 stays the same, and then I drop off everything after the 5. So I would get 32.05. All right. What if I had 56.895? All right. Rounding digit is the 9. The digit to the right is a 5, which tells me to round up. So remember, when you round up, it gets kind of weird. Well, when you round up, when you have a 9, it gets kind of weird. If I add 1 to 9, that makes it a 10. Okay. And then I carry the 1 to the 8. So 1 plus 8 is 9. And then I've got my 56. But remember what I told you, when you're dealing with decimals, those zeros at the end are unnecessary. It's kind of like a fraction that's not reduced. So you want to drop off zeros at the end unless you're dealing with money. So we get approximately 56.9. What if I asked you to round to the nearest cent? Now, when we're talking money, we have dollars and we have cents. And when we have money, we always have 2 decimal places. So if I had something like this, and it said gas was $2.49.9, okay? Well, if I wanted to round to the hundredths place, right here, I have my rounding digit 9. I look directly to the right of that. I have another 9, which tells me to round up. So I add 1 to the 9, okay? That makes it 10, so I keep the 0. I carry the 1 to the 4. 4 plus 1 is 5. And then I keep everything before the decimal as is. Now, in this case, which is a tiny bit different than the previous example, in this case, we go ahead and we leave the decimal, all right? We leave the decimal, the 5, and the 0. You don't want to get rid of this 0 only when dealing with money. So keep this 0. When dealing with money. Okay. Now, let's say I said round to the nearest dollar. And let's say in this case, I had $568.43. Well, the dollars would be the ones place. So when you're dealing with money, cent is the hundredths place, dollar is the ones place before the decimal. So in this case, the ones place is the 8. I look to the right to the 4. Well, 4 tells me to round down. So this would round to approximately $568. What if I had $23.72? Still rounding to the nearest dollar. So the 3, which is in the ones place, is going to tell me where to round. I look to the right. I have a 7. The 7 tells me to round up. So in this case, this would round to approximately $24. Okay, so rounding, whether before or after the decimal place, is almost identical. You locate your rounding digit by place value. The digit to the right of that tells you if you round up or down. Rounding up, you add 1 to the rounding digit. And if you're rounding before the decimal place, everything after that would become 0. If you're rounding after the decimal place, everything after that would just get chopped off. Now, rounding down, you leave the rounding digit alone. And then if you're before the decimal, everything after becomes 0. If you're after the decimal, everything after becomes, it just gets chopped off. Okay. Let's look at comparing decimals. So we're going to shift gears a little bit. So we're going to go from rounding to comparing. So here's the deal. Let's talk about this. So let's say we have 7/10 versus 7/100. Okay, I know this is weird because I'm telling you we're going to compare decimals. But let's go ahead and compare fractions first, because that's something that we kind of know how to do. If you want to ever compare fractions, we know that as long as the denominators are the same, we can just compare the numerators, okay? So in a problem like this, I'd be like, oh, shoot, I don't have common denominators. That's okay. 10 goes into 100, so I know that 100 is the LCD. To get 100, I would multiply top and bottom of the first fraction by 10. So that would then give me 70 hundredths versus 7 hundredths. And we would say that 70 hundredths is bigger, because 70 is bigger than 7. Now let's look at how that would compare to decimals, okay? Now we already know how to write fractions with powers of 10 in the denominator as decimals, so let's do that, okay? Now for 7/10, I've got 1 0 in my power of 10, so that tells me I'm gonna have one decimal place filled with a 7. And then for 70, or for 7 hundredths, I have, well, 2 decimal places because I have 2 zeros in my power of 10, and I fill that in with a 7. So that's what our decimals would look like. I could say, okay, compare rather 0.7 to 0.07, which is bigger? Well, here's what you do. You kind of do the equivalent of finding the LCD, but it's a heck of a lot easier with decimals. All you want to do is add zeros to the end of your decimals until you have the same number of decimal places. So all I had to do here was add a 0 after 7, and that gave me 0.70. We know it's equivalent. It's kind of like saying 7/10 is equivalent to 71 hundredths. All right. And then you really just compare 70 to 7. You just compare the numbers after the decimal place. Well, which of these is bigger? Well, 70 is bigger, so 0.7 is greater than 0.07. Okay, let's look at some more of those. What if I had you compare, okay, and I had you compare 0.13 to 0.013? Well, all I have to do is add zeros to the end of the numbers so they all have the same number of decimal places, okay? So what I'm really comparing is 130 to 13. Well, which is bigger? 130 is definitely bigger, so we would say, I'm gonna remove that for now. We would say that 0.13 is bigger than 0.013. Let's try another one. Got a little crazy there. So what if I have 0.205 and I want to compare it to 0.25? Well, again, all we have to do is add those zeros at the end of the number. So I would be comparing 205 to 250. Well, which is bigger? In this case, 250 is definitely bigger. So 205 is less than 250. So that tells me that 0.205 is less than 0.25. All right. What if I had 0.011 versus 0.101? Okay. Once you get the hang of what you're really doing, this becomes super duper easy and you don't really have to do a whole lot of work. Now, in this case, each of these numbers already has 3 decimal places. So what we're really doing is we're comparing 11 to 101. Well, which is bigger? 11 is less than 101 by a good bit. So we would then say that 0.011 is less than 0.101. What if I have 0.0413 and I wanted to compare that to 0.4013? Okay, again, once you get the gist of this, it's super duper easy to do. So looking at these two numbers, they each have 4 decimal places. Remember, decimal places are just the number of digits after the 0. Okay, so what I would do is compare them as if they were whole numbers. 413 compared to 4013, which is bigger? 4013 is way bigger. So we would say 0.1 or 0.0413 is definitely less than 0.4013. Let's do one more. This is another easy one. You've already got 4 decimal places in both numbers. So what we're really comparing is 3031 versus 1031. Well, which one's bigger? 3031 is much bigger. So we would say 0.3031 is bigger than 0.1031. Okay. So as long as your numbers have the same number of decimal places, it's easy to compare. You compare the two numbers as if they were whole numbers. I do also want to point out in all of these cases, everything before the decimal matched. Okay. So what if I did something like this? I'm going to do one over in this little corner here. What if I said I had 3.291 and I wanted to compare that to 2.291? Well, you don't even need to worry about the decimals in this case. 3 is bigger than 2. So 3.291 is obviously going to be bigger than 2.291. Okay. Now, in the event that you don't have the same number of decimal places, you just add those zeros in. All right. And then you compare your numbers as if they were whole. Next up, we can talk about ordering decimals. Generally, when you're ordering decimals, you're putting them in order smallest to largest. There could be situations where you'd want to put them in order from largest to smallest. Just read the directions. Okay. But let's say that we have 0.025, 0.205, 0.2015, 0.2105. And then let's say we had 0.25. Okay, so we've got 5 decimals that we want to put in order, and we are going to go smallest to largest. Okay, now when I look at these numbers, I have 2 decimal places, 3 decimal places, and 4 decimal places. So what I'm going to do first is I'm going to add those zeros at the end. So I'm going to write this as 0.0250, 0.2050, 0.2015 already has 4 decimals. Since the largest number of decimal places in one number was 4, that's what I'm going to go for. 0.210, hold on, let me fix that. 05, and then for this one, I'm going to write it as 0.2500. All of these now have 4 decimal places. Okay, so now we're going to look at these numbers as if they were whole numbers. We have 250 versus 2050 versus 2015 versus 2105 versus 2500. Okay, so now we want to find the number that is the smallest. So I'm going to start numbering these 1 through 5, 1 being the smallest, 5 being the largest. Well, 250 is the smallest, so that's going to be my first number in line. Okay. Next, I have 2015. That's going to be my second number in line. And then I've got 2050, 2105, and then 2500. So next would be 2050. And then for my last 2 numbers, I have 2100 versus 2500 and something. So the 2100 and something is way less than the 2500 and something. So smallest to largest, I'm going to write the numbers back out, but I'm going to write out the original numbers. So my smallest number was 0.025. My next smallest number was 0.2015. I then have 0.205, 0.2105, and finally 0.25. Let's do another one like that. What if I had 1.031, 1.301, getting ahead of myself, 1.3, 1.13, and then let's say I had 1.31. Okay, So I've got anywhere from 3 decimal places to 1 decimal place. I want all of these to have the same number of decimal places, which would be 3. So I'm going to rewrite all of them. I've got 1.031, 1.301, 1.300. I got to add 2 zeros to give it 3 decimal places. 1.130 and 1.310. Everything now has 3 decimal places. Now this is unique compared to the previous example. Everything was just a decimal. There was no whole number. But for this example, we do have whole numbers. So are all of the whole numbers the same? Yes. So we're not going to worry about the 1 in front of the decimal. So we're just going to look at the decimal parts. So we're really comparing 31, 301, 300, 130, and 310. Okay, so smallest to largest, our smallest number is 31. Our second smallest number is 130. And then we have 300, 301, and 310. So let's put those numbers back in order, but we're going to put the original numbers in order. So I get 1.031, 1.13, 1.3, 1.301, and then finally 1.31. And that is from smallest to largest. Okay. So quick recap on this video. Rounding decimals, very similar to rounding whole numbers. The only difference is once you decide to round up or down, instead of making everything after the rounding digit 0, you just drop off all of the digits after the rounding 0. We did some examples. We also found in an example like this, if your last digit is 0, you always knock it off. It's kind of like reducing a fraction. You just always write your answer in reduced form. So when you're dealing with decimals, don't leave those extra zeros at the end. The only exception to that would be if you had money. So like right here, we rounded to the nearest cent. So it really ended up rounding to 2.5, but because we were dealing with money, we wanted to write it as $2.50. So that 0 is okay, you keep it. Let's see, we talked about comparing decimals. We looked at how we would compare fractions, and then we converted that to decimals and figured out that really, as long as you have the same number of decimal places, you just compare as if the numbers were whole numbers. So we did several examples of that. We then looked at ordering numbers. It's the same thing. You just make sure all of your numbers have the same number of decimal places. Put the numbers in order as if they were whole numbers, but always remember for your final answer, write out the original decimals. Do the side work. The blue and the red would basically, like all of this would be my side work, but I want my final answer to always look like the original decimals. Okay. And we did another example of that, and that was that. Okay. So in this video, again, we talked about rounding. I'm still like kind of worried about my hair right here. Anyway, we talked about rounding decimals. It's not so bad. If you can round whole numbers, you can certainly round decimals. We talked about comparing. We talked about ordering. Next video, we're going to talk about converting all fractions to decimals. So not just those fractions that have powers of 10 as the denominator, but all fractions. So we'll learn how to convert all fractions to decimals. And then we'll look at comparing decimals and fractions to each other. We'll look at putting a series of fractions and decimals in order as well. All right. Best of luck.